We're with the OU Department of Civil Engineering. My name is Stephanie Castillo.
My name is AlexandraLiever, and this poster is on investigating freeze-thaw behavior of nano-modified fiber-reinforced polymers. ASCE reported in 2021 that our country's infrastructure is graded at a C-. Construction materials can deteriorate quickly when exposed to the environment and are difficult to maintain, damaging performance and leading to unsafe structures. Transportation infrastructure like bridges and highways accumulate freeze-thaw damage quicker than ever with the rapidly changing climate. How can we improve this situation? We must use new technology and materials, like fiber-reinforced polymers.
Fiber-reinforced polymers are becoming more popular in the construction industry because of their many positive properties like high strength-to-weight ratio. One of the major negative properties of FRPs, however, is the ability to be damaged by freeze-thaw cycles. In Oklahoma, there are around 60 freeze-thaw cycles per year. Once moisture seeps into the pores of the material, each cycle freezes the water, creating expansive forces and permanently damaging the material. One potential preventative measure for this damage is the addition of carbon nanotubes into the FRP matrix, which could help with bond strength. Our research goals are to understand the microscopic debonding that is happening in the FRP through many cycles, as well as to understand how the number of freeze-thaw cycles and the concentration of carbon nanotubes affects mechanical properties.
To achieve these research goals, we cast carbon fiber FRP plates with hand layup method and expose these samples to freeze-thaw cycles. To determine how mechanical properties had changed, tensile tests were performed on on-axis and off-axis specimens. On-axis specimens have fiber that is in the direction of loading, while off-axis specimens have fiber at a 45-degree angle to the direction of loading.
We exposed two different types of nanotubes to freeze-thaw cycles, pristine and functional, which contains a carboxyl group. An additional plate with no nanotubes, called neat, was made as a control. Scanning electron microscope images shown here show apparent dispersion of the nanotubes in the matrix. No clumps are visible, which can be a challenge when working with carbon nanotubes. The graph shown here shows strength of the FRP over 80 freeze-thaw cycles tested on axis. Because there is not an obvious trend visible, we concluded that the number of freeze-thaw cycles should be increased to see long-term damage. This also spurred our decision to do off-axis testing to isolate the matrix behavior, since the freeze-thaw may be affecting the matrix more significantly than the fibers, which account for most of on-axis strength. Trends in strength are expected to be more visible with this method.